Hey guys, today's video is on circles, arcs, angles. So some vocabulary. The first thing that we need to know are what these different pieces are. So if you have, we'll start with this one right here. So if you have a line that goes through your circle and it's intersecting, but it goes through it, that's your secant. A chord is going to connect two parts of the circle, so 2 points that are on the circle. If it's a diameter, a diameter is a special chord that actually goes through the center of the circle. So there's your center. The diameter is any line that goes through that center point. And then a radius, again, goes from the center to the circle, and that can be anywhere from the center to the circle. And the tangent is going to be a line that touches that circle in only one point, and that point has a special name called that point of tangency. Okay, some other vocabulary. Vertical angle, so V on V, right? V on V, look for a big X, and vertical angles are congruent. So the ones that are opposite from each other, the 2 and the 4 and the 1 and the 3, those are congruent to each other. They are always congruent because vertical angles are congruent. Okay, arcs. You have minor arcs and major arcs. The minor arc is going to be less than 180 degrees, and your major arcs are greater than 180 degrees. The little ones, the minor ones, are named by 2 letters, and the major ones are named by 3 letters. So your minor arc here would be that arc AB. Your major arc, you'd have to have another letter down here to call that A, maybe, I don't know, ADB if there was another letter down here. Your semicircle is going to be half of your circle. So your diameter would be coming across here would be DE going through the center C, but there's your 180 degree angle, which is your semicircle. A chord is labeled as going from your point on the circle to another point on the circle. So you're connecting 2 points that are on your circle through your circle. But you're going to call that chord the line segment, right? LM is the chord. But if you put a curve on top of it, then that would be the minor arc, LM. If it was going this way, then that would be the major arc, LNM. Let's see. And then this one, you would say, so I would have to talk about this angle right here, BDC, BDC. That arc right here would be my larger arc because that is going to be 250 degrees, because if your central angle is 250, then your arc is 250. We're going to get to that in a little bit. And then your minor one here would be 360 minus 251, whatever that angle is, would be this little major arc or minor arc, BC. So if I added those together, this one would equal 251 degrees, and then that would be 360 minus 250 would be 109. And again, we've already talked about that. Okay. And then on your next page, so on that previous page, when I just said that inside angle was 250 degrees, so I said this outside arc had to be that same 251, I think it was 251 degrees. That's because central angles are equal to the arc. So if you know what this inside central angle has to be on the center of the circle, if you know what your central angle is, the arc that matches up to those where the angle ends on your circle, that arc is equal to it. Excuse me. So central angles are equal to the arc. Then we have angles that are on the circle. And if you're on the circle, then that's called an inscribed angle. So it's not going to be equal. The arc is not going to be equal because you're not at the center, but it's actually going to be half of it because you're scooting back even further. So it's not equal to it. It's half of that. So if I know whatever this arc is out here, then half of that arc is going to be equal to this angle formed inside here. Or if you know what the angle is, then you would double that to get back out to the arc. Okay, so central angles equal your arcs. Inscribed angles are half of your arcs. And here's another one. You could have angles that are inside. If it's an inside angle, so remember how these two right here are vertical angles and they're equal to each other? But obviously these arcs aren't equal to each other. So you're going to find the average of those arcs. So we're going to say, what is this outside arc, X, plus this other side arc, Y? We're going to add them together and divide by 2, or 1/2 of the sum. Half of the sum is your internal angles. Well, if you can have internal angles, we can also have external angles. And if we're adding to find the average or the half the sum, if you're adding for the inside, then we're going to do the opposite and subtract for the outside. And I remember it as big minus small divide by 2. Exterior angles, you're going to have a larger arc minus the smaller arc, and you're going to cut it in half. And then on the bottom, this is just showing you how you can get those exterior angles. So we can have an exterior angle like the one formed up here. That's this picture here where you have a large arc minus a small arc divided by 2. Well, those large and small arcs can be formed differently. See how this one actually is formed by 2 secants. This is formed by 2 tangents. Well, tangents only touch in one place. So what you're going to have here is you're going to have an arc. The outside ones, right? This one out here is the larger one from P around to the R, PQR. And then I've got the smaller one that just goes from P to R. So it would be the measure of angle PQR minus this red one, divide by 2. Big minus little, divide by 2. So 2 secants, 2 tangents, or you can have a tangent and a secant. It doesn't matter, y'all. The formula is the same. The angle is outside. So don't get so caught up in how they're being formed. They're all the same way. It's still going to be that larger angle, your big angle. I said angle, arc. I apologize. These are your arcs. Your big arc minus your little arc divided by 2. All of them. So this one was formed by a secant and a tangent. These are 2 tangents, and these are 2 secants, but it doesn't matter. We're going to do them all the same way, and it's going to be the big arc minus the small arc divided by 2. So a quick recap. If you have angle that is at the center of your circle, it's called a central angle, then they equal the arc. If your angle is on the circle, it's half the arc. If it's inside, then we're going to take the average, we're going to add the arcs and divide by 2. And if it's outside, then we're going to have to do subtraction. We're going to say the big arc minus the little arc divided by 2. And remember, those can be formed different ways, but it's always big arc minus little arc divided by 2. Big arc minus little arc divided by 2. Big arc minus little arc divided by 2. We keep going back. Okay, so what we're going to do, what we would be doing in class, so I'm just going to kind of set you up the same way, is in class we're going to work through some of these odd ones. So for homework, you're going to do the evens. All right, so again, for time's sake, I've already worked out some of these for us. So I'm just going to cover up those because I want to stay focused on just the odds so I remember which ones I'm doing. Okay, so for this problem, first of all, it says find the measure of the arc or central angle indicated and assume that lines which appear to be diameters are actual diameters. Okay, so looking at this problem, they want me to find x, u, z, the measure of angle x, u, z. X, u, z. I want to know what is that angle in here, which means I'm missing this part right here. So it looks like, so they told me I can assume that W, U, Z is a diameter. So that's 180 degrees for this whole arc right here, which would mean that all three of those angles have to equal 180 degrees. So 180 minus the 52 minus the 51 that I already know, leave me with that 77 to fill in here. And then remember, they only want X, U, Z. They only want those two. So when I add those two together, that's my answer, 128. For number 3 wants the arc YV. From YV, this arc, I already know it's 45, but I need to figure out what is this ZY. Well, y'all, we got all these other arcs, 45, 70, 90, 120. We've got all the arcs except for this one. All the way around a circle is 360 degrees. So 360 degrees minus the 120, minus the 90, minus the 70, minus the 45 is going to tell me this little piece that I'm left over with here, which is 35. And then I take that 35, add it to the 45 to get these two together, which form that VY, or the arc, yes, the arc VY or YV is what it's actually order it said it in. TU. So again, this is all the way across. That's 180 degrees. So 180 minus 55 minus 83 is going to tell you what this guy is right here. And that's what you want. So 180 minus the 83 minus the 55 is going to tell you what you're left over with here. And 42 is actually what you wanted for the answer. That's what the question was. Okay, number 7 says find the measure of the arc or the angle that is indicated. So this arc right here is 120 degrees, and it starts here and it ends here. And I have an angle that connects that Q and connects that R. So that angle opens up to this arc. So I'm on the circle. It's going to be half of the arc. So half of 120. The answer is 160. That's one of those inscribed angles. Okay, number 9, same directions. This time, I want to find the arc GFE. Well, from G all the way around from F ending at E. So the angle that opens up to those 2 points would be this guy right here, right? So that angle is on the circle. It's half of the arc. So if I doubled that, I would get the arc. So 2 times 105 gives you that whole arc. This time you want to find DC, or you want to find that X. So from here to here, let's see. Again, I've got this angle, 59, that sits on the circle, opens up to the arc that I'm asked for. So if I double that 59, it's going to equal 118. Y'all, this reminds me of another one. Look, if this angle B opens up to the exact same arc, then angle R has to be congruent with angle B because they both open up to that same arc. So If I figured out that this was 118, then that angle would be half of 118, which is going backwards to get the 59. So 59 and 59 are equal to each other. All right, 13 and 15 say find the measure of the arc or angle indicated and assume that tangents are tangent. If they look like a tangent, they're tangent. My angle is outside. If it's outside, then I know I've got an arc here that's a big arc, 130, minus a little arc right here, which is 60, because see how it touches here and here? So there's my little arc. And then it touches again from here to here. There's your big arc. So 130 minus 60, take half of that, and your answer would be 35. Outside again. Where does that touch? It touches right here. So there's my first unknown, which is what I'm trying to find, x. And then it touches again at the L and the D. And that opens up to this arc here that's 170. So the math would be 170 minus x divided by 2 equals 57. So I would bring that 2 over to this side and double it and get 114 equals 170 minus x. Subtract the 170, and if negative x equals negative 56, then my positive x would be a positive 56. Outside, big arc minus little arc, divide by 2 equals the angle. Alrighty, and then number 17. Okay, y'all, this says honors on this, but I'm going to show it to you because it's possible that you might end up with something like this, and there's no reason why you can't do it also. Okay, this is where the state would give you one of these questions so that the students who have always scored a level 5 can show that they've had growth too. All right, so here we go. We're on the outside. Ooh, this is a tangent here. So it touches only here and here. So that means that you've got this tiny little piece right here, and then you've got the whole other circle out here. And they want that whole other circle. And they're telling you that the outside angle here is 45. So this is why this one's a teeny bit tricky. Okay, so first of all, you're going to say the large arc, X, minus the small one. Well, y'all, I don't know what that small one is. But what I do know is the whole circle is 360 degrees. And this little piece right here is X. So my DB is going to be 360, the whole circle, minus the part that I already know. And that's the trick to this one. Okay, so here we go. Because what do you know? Big arc minus little arc divided by 2 or times half is equal to that angle. So we do a little math here and we say this is going to be x minus 360 plus x. So that's 2 x's. When you bring the 360 to the other side, you get your 450. So then your x is 225. So if you're only given one variable and it's the whole circle and it's only touching at 2 places, so you have the top part of the circle and the bottom part of the circle, then that's when you're going to do that 360 minus x part, usually to set those up. All right, well, 19 and 20, actually 19, 21, and 23 are all inside, so those are the averages. Now we're not subtracting, we're adding. So outside 135 plus 65, divide by 2 to get your answer. The outsides again, so that would be 55 plus x divided by 2 equals 65. So again, the math, I would have to say, okay, I want to get that x by itself, so let's move that 2 over here. So I'm going to multiply by 2, subtract 55. All right, so 23, a little bit more math with this one. The outside arcs, add them together, divide by 2, that's going to give you the inside angle. So this 8 plus 16x plus the other outside one, 4x plus 6, divide by 2, multiply by 1/2, is equal to that inside 11x minus 5. So this one's just full on algebra. If you bring the 2 over here, you're going to double it. So that's going to become 2 times 11x minus 5. And then inside here, if we clean up, that 16 and 4 give you a 20x, and the 8 and the 6 give you a 14. Distributing, 2 times 11 is 22x. 2 times negative 5 is negative 10. Bring the 20x over here, leaves you with a 2x. Add the 10 to this side, gives you a 24. So your x is 12. Be careful. They want TK. TK is this guy, and that is 4x plus 6. So 4 times 12 plus 6, your answer is 54 degrees. Make sure you know what they're asking you to solve for in that case. And then the last one, I believe this is our last one. You're outside again. So remember, that's the big arc minus the little arc. Well, the big arc here is 9x plus 12 minus your little arc, which is 50. So I'm going to take that, divide by 2, and it's equal to that angle that's outside, which is 2x plus 11. So again, if I double it, if I move that 2 to the other side, I'm going to multiply by 2. That gives me a 4x plus 22. And then in here, this piece is a 9x minus 38. So I can subtract that 4, add that 38, gives you a 60 equals 5x. And then divide through by 5 gives you 12. So then they wanted EFH. EFH is this angle, 2x plus 11. So 2 times 12, 2x plus 11, 2 times 12 plus 11 is 35 degrees. Okay, y'all, so that was it. What I'd like you to do now is just go back and work on the evens. And I hope that helped. Bye.